Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Hidayah with student ID number 202432059 from the Information System Study Program. So in this occasion, I would like to explain about my second practicum report in machine learning lecture. So here are the code that I used to do this practicum. So here's the analysis. So the process begins by importing the necessary programming libraries. And the first line, import pandas SPD, loads the pandas library, which is used to manage and manipulate tabular data structures called data frames. And then next, import matplotlib pyplot as PLT calls the core module of matplotlib to handle the background figure canvas, adjust plot size, and render graphs onto the screen. And to make the statistical charts look clean and modern, the line import C1 SNS is executed because this library operates seamlessly on top of matplotlib using much simpler syntax. And then following that, the line from sklearn model selection import train test split extracts a specialized function used to split the dataset into separate training and testing subsets randomly. And the line from sklearn ensemble import random forest classifier is then called to import a decision tree based algorithm that will act as our predictive machine learning model. And this setup phase concludes with from sklearn matrix import confusion matrix, which imports the mathematical cross tabulation in error calculator alongside its native graphical display module. And then now we move into the data management phase, the line df. So df pd read csv. Here we use to read our custom CSV file into the computer's memory as a structured table assigned to the variable df. And the subsequent line df head automatically prints the first 5 rows of the table to help us inspect column names and the raw data layout. And continuing the early exploration, the line df info provides technical metadata showing the total number of entries, missing or null values, and how Python stores each data column. To wrap up the initial data overview, the line df describe automatically computes fatal summary statistics, including the mean, standard deviance, minimum, maximum, and quartile thresholds for every column containing numerical data types. And then during the preprocessing stage, the line X df drop columns isolates the independent variables or features by removing text-based columns that cannot be directly computed by the mathematical algorithm, as well as dropping in irrelevant student identification strings. So conversely, the line YDF burnout the risk level defines the dependent target column containing the specific classification categories we want the model to learn and predict. Once the inputs and targets are separate, the line X train, X test, Y train, Y test here partitions the rows, allocating 80% of the data to train the model's intelligence and reserving the remaining 20% as an unseen test bench for validation. While the random state 42 parameter ensures this data split remains perfectly consistent every time the notebook is run. So in the model training phase, the line model random forest classifier initialize an empty, untrained classifier object that is ready to be configured. The actual training process kicks off on the line model fit xtrain ytrain, where the algorithm actively analyzes the patterns and correlations between the students' features and their true burnout levels. Once this learning process is complete, the line ypred or model predict evaluates the model's predictive capabilities by commanding it to guess the burnout risk level for the test features, saving those output predictions inside the variable ypred. And then the final stage is dedicated to rendering the model's performance as a clear graphics chart. The line SNS setThem configures the global visualization template to have a clean aesthetic backdrop complete with faint grind lines. Then the line CM confusion matrix cross-tabulates the true validation answers against the model's predictions according to our specified label order. The resulting raw numbers are wrapped by the line. This display confusion matrix display to prepare the data matrix layout for graphical translation, and then the line PLT figure here we use to set up as a clear 8.6-inch display window to prevent internal text elements from overlapping. And the evaluation chart is plotted via the line display plot CMap blues, which styles the grid box with a smooth blue gradient and forces the text inside to display as standard whole integers. And then to provide proper context, the line PLT title adds a main heading to the top of the canvas. And the line PLT grid is explicitly run of the global seaboard grid lines so that they do not accidentally slice through the matrix squares. This entire visualization sequence concludes with the accidentally sliced through the matrix squares. And then this entire visualization sequence concludes with the line PLT show, which commands Python to render and output the Clayton classification performance matrix directly into your Jupyter notebook. Maybe that's all from me. Wassalamualaikum warahmatullahi wabarakatuh.